Okay, I'm going to show you guys translation with stop motion animation, and it will take like 10 seconds to show. So don't blink. Okay, here we go. All right, I'm going to go one more time but slower. Up here. Okay, now I'm going to describe it a little bit and then we'll do the notes and we will be done. Okay. So there is methionine, and when it attaches to the start codon, which for some reason is not always first, but it is always the first tRNA that is brought in. So there might be some superfluous extra mRNA right there, so you always find your start codon. The methionine causes the ribosome to be assembled. The ribosome has the capacity to carry 1, 2, 3 tRNAs. So the first thing that happens is a new tRNA is brought in with its new amino acid. A peptide bond is formed. Watch right here. The bond is released. The ribosome scooches over. In comes a new one. Bond, release, move over. New tRNA, bond, release, move over. New tRNA, bond, release, move over. New tRNA, in this case, it is not an amino acid one, it is your stop codon. It does not bring an amino acid in, it causes everything to fall apart, and you are left with your final product, a polypeptide chain. So please go to this paper right here that we did together in class, open up to the animations. This is translation. This is going to be the process that converts your mRNA into your polypeptide. And this is going to occur on a ribosome. A ribosome is made up of two parts. It has a large subunit right here, and it has a small subunit together right there, and they're not together until they receive the signal to come together, which is the attachment of your start codon with methionine amino acid at the top. So this is your large subunit. This is your small subunit. And this entire thing right here is a ribosome. So this is a ribosome. Okay. So let's zoom in on this box, but before I zoom, I actually want to number the steps. So you only have steps on this side, but over here are repeats, just showing it happening again. So I'm going to number the steps. 1, 2, 3, 4, 5, 6, 7. And I go over here. This is just a repeat, repeat, repeat. Here's a step right here. Step 8, that ends the whole thing, and then this is step 9 that shows everything broken down, and this is not a step, this is just your final product. So I'm going to go up here and I'm going to write my notes in. So this one is attachment of the MET, methionine amino acid, causes ribosome assembly. Right? The ribosome is now assembled, and it has the capacity to hold 1, 2, 3 tRNAs. This set right here is labeled E, and that stands for eject. It's going to push off a tRNA. A is opposite. It's going to stand for accept. So this is where you eject an old. This is where you receive a new amino acid. Okay. All this picture is showing from this picture is simply an assembled ribosome. Okay, let's move down. It's going to get started. So here we have a new tRNA on the A site. So we have a new tRNA on the A for accept site, right? Next thing that happens is super simple. They form together something called a peptide bond. It's a special type of bond found between the 20 amino acids. So a peptide bond is formed. A peptide bond is formed between amino acids. Okay. Now we move to this picture. The only thing different between these two pictures is the amino acid that is once there is now released. So I'm going to put an X right here. The amino acid on the P site is removed from tRNA. Okay, here the only thing different is this has moved over one codon. So now this codon that is right here, UGU, is now right there. So the ribosome has moved over one codon to the right. So ribosome moves over by one codon. All right, now the A site is exposed. So we have in with the new. This is a new tRNA. It's fully loaded with its amino acid. So in with the new, out with the old. This was your old tRNA that has already been reused. It needs to go into your cytoplasm to get refreshed with methionine again because it gave up its methionine just a few seconds ago. Okay, so it's just a process of putting in a new amino acid, forming a bond, breaking that bond right there, and continuing to grow your polypeptide until you finish. So right here, you have a peptide bond forms. The bond right there breaks. The ribosome moves over. And then you repeat until a stop codon. Some proteins are like 50,000 amino acids long. But maybe just 15,000. That was an exaggeration. I believe it's 15,000 amino acids long for the biggest one. And then the ribosome reaches right here, UGA. This is your stop codon. Okay, so the stop codon is reached. Okay, I don't know why I have an empty box here. Everything detaches from each other. All right. Scroll down here. Your final product is your polypeptide. And just for review, each of these circles right here represents one of the 20 amino acids. So these are all amino acids. Okay, and the bond that forms between these amino acids is called a peptide bond. Okay, I want to finish with showing this just one more time. Went too far. There's your final product.